Hey and welcome back to this next video in your organic chemistry chapter. In this video we will learn how to draw the Lewis structure. The Lewis structure is a way how we can actually draw the structure, the chemical structure and the makeup of molecules in chemistry. And it shows the structure as well as the orientation in space. Very important for the understanding of Lewis structure is the knowledge of the periodic table of elements. Mainly, we need to know about valence electrons and the octet rule. So you remember again that hydrogen is in group 1 and therefore has 1 electron in its valence shell. You also remember that boron is in the third group, therefore has 3 electrons in its valence shell. Carbon has 4, nitrogen 5, oxygen 6, fluorine 7, and neon over here 8. And you also remember that to fulfill the octet rule, each atom over here needs 8 valence electrons in its outermost shell, in the valence shell. Only hydrogen falls out of the picture here because it only needs 2 to fulfill its octet rule. I also want to quickly show you, so you won't be confused, examples of how you can actually draw the relationship of electrons to the atoms. If you see a hydrogen over here connected with this line, or with this line connected to some other element, you know that this is a covalent bond where actually 2 electrons are shared from one element to another to fulfill the octet rule in covalent bonding. This can also be drawn like this, where we actually draw 2 dots. So 2 dots are the same as one line, and one line always depicts 2 electrons, such as 2 dots do. Other examples here are, for instance, this. If we have a carbon with 4 lines attached, this is actually depicting 8 electrons, such as we could also draw it like this. The same goes for nitrogen over here and also for oxygen and fluorine. I just want you to remember that one line is 2 electrons, so you won't be confused. So now let's actually get into how we can draw a Lewis structure. The Lewis structure is important because it not only tells us something about the chemical makeup, but also about somewhat the orientation of this molecule in space. For example, over here we have our nitrate. Let's just take nitrate as an example to learn how to draw the Lewis structure. We have written up 5 very important rules that you have to follow to perfectly draw a Lewis structure. And with this example, we will now follow through and draw the Lewis structure for nitrate. So the first rule would be to determine the number of valence electrons. We know that nitrogen over here from the periodic table of elements has 5 valence electrons, so we will count 5. Then we know that oxygen has 6 valence electrons, so we will know that we have to take 3 times 6 because we actually have O3, so we have 3 oxygens. 3 times 6, you know, is 18. And then don't forget, we also have an overall charge over here of -1. -1 actually, you know, also means that we have 1 more electron. So we will add 1 more. Overall, this will yield us 24 electrons that are used in the structure of nitrate. The next rule would be that we have to write the skeleton structure using single bonds. So we just want to connect those elements as simply as possible. So we have written down the nitrogen in the middle and we connect all the oxygens in a very geometrical fashion over here. And now if we count all the electrons that we've used, and it's important you only use single bonds at first, we can count that we have 1, 2, 3, 4, 5, 6 electrons that we have overall used. Out of, remember, 24 that we counted we need in our nitrate. So this is where the rule number 3 comes in handy, and we now have to assign the remaining valence electrons, which are 18. So now let's just go around and give all the 18 electrons we have left to our oxygens over here. So now we actually added 6 electrons on this oxygen, 6 electrons on the right one up here, and 6 also down here. Perfect. We now used all of our 24 electrons to draw this Lewis structure. Now, let's go to rule number 4. It says that we have to make multiple bonds if all octet rules aren't fulfilled. So let's check the octet rules. So for our oxygen down here, we can count 1, 2, 3, 4, 5, 6, 7, and the number 8 is covalently shared with the nitrogen. So octet rule for this one is perfectly fulfilled. This same thing goes for the oxygen up here. We can count 1, 2, 3, 4, 5, 6, 7, 8 covalently shared with the nitrogen. Perfect. And the same one for the top right. But the octet rule for this nitrogen down here is actually not fulfilled. we can only count 1, 2, 3, 4, 5, 6 electrons that the nitrogen can actually use, and therefore the octet rule is not fulfilled. All right. To actually then fulfill this octet rule you just saw, we can make a multiple bond. So we formed a double bond from one of this lone pair of electrons down here. Let's see it again. We will just move one of those lone pairs in the middle to again covalently share those electrons too with our nitrogen. And now our nitrogen in the middle can count for itself 1, 2, 3, 4, 5, 6, 7, 8 electrons. And it is now completely fulfilling the octet rule. Perfect. So rule number 5, the question, is there a net charge? To answer this question, if there is a net charge, we actually have to look at all of our elements, all of our atoms that were actually used in the Lewis structure. Over here you can see that in the close vicinity of oxygen is 1, 2, 3, 4, 5, 6, 7 electrons. The 8 electrons for the valence shell we don't count as the inner closest electrons to this oxygen. So there are 7 electrons that are really, really close to this oxygen. And this, if you remember, is one too many electrons. Oxygen would like 6 electrons in its valence shell, so we will give it a number of -1, since it has one more electron and therefore has a net charge of -1. The same goes for this oxygen over here, where we can count it as 1, 2, 3, 4, 5, 6, and also 7. 7 from this bond that are actually closely related to this oxygen. So this oxygen will also get a net charge of -1. If we count this oxygen down here, we can count that closely relating electrons to this oxygen are 1, 2, 3, 4, 5, and 6. And the closest one to the nitrogens, we of course don't count, so we have 6 closely relating electrons to this oxygen. So it actually matches its amount of valence electrons it actually wants, so therefore we will assign the number 0 for the net charge question to this one. For our nitrogen in the middle, let's count. We can count that we have 1, 2, 3, 4 electrons that are closely relating to only this nitrogen. We know from the periodic table of elements that nitrogen would want 5 valence electrons in its shell. And since this situation is not fulfilling the 5 and it's 1 too short, we will assign the number +1 because it is 1 electron too little. In the end, we just have to add up all those numbers and this would give us an overall charge of -1. And we actually write this as big brackets over here and then the -1 as the overall -1 charge for this Lewis structure over here. And you can see that we can imagine how this compound now actually looks in its relation to electrons and also to each other with the amount of bonds that it is forming. Thank you so much for watching this video.